For most of its life, a star should be predictable. It burns, it shines, and from hundreds or even thousands of light years away, its brightness may change only slightly. But in the constellation Cygnus, astronomers found a star doing something that seemed almost impossible. It was disappearing. Not completely, not for long, but sometimes its light would suddenly drop by an extraordinary amount and then return. The star became known as Tabby's star, officially KIC 8462852A. And the deeper astronomers looked, the stranger the pattern became. The first clue came from data collected by NASA's Kepler Space Telescope. Kepler was designed to find planets by watching stars for tiny, regular dips in brightness. When a planet passes between its star and Earth, it blocks a small fraction of the starlight. For a typical planet, the pattern is beautifully simple. A dip, then recovery. And after the planet completes another orbit, the same dip happens again. But Tabby's star did not behave that way. Its brightness fell by large and irregular amounts. Some of the dips were only a little noticeable, others were dramatic, and they did not appear at perfectly regular intervals, as they would if a normal planet were crossing the star. It was as if something enormous was passing in front of the star, but without following the neat schedule expected from a planet. That immediately created a problem. What could block that much light? Imagine looking at a distant lighthouse and suddenly seeing a large section of its beam disappear. You would naturally suspect something had crossed in front of it. But if the blockage happened at unpredictable times, lasted for different lengths of time, and sometimes became remarkably deep, the obvious explanation would begin to fail. Astronomers started investigating, and Tabby's star became one of the most unusual objects in the Kepler data. One possibility was simple. Perhaps a giant cloud of dust was passing between the star and Earth. Dust can block starlight. Comets can produce dust. Collisions between objects can create enormous clouds of debris, and large amounts of material orbiting a star could, in principle, produce strange changes in brightness. But there was a complication. The amount of material required to explain some of the deepest dips would be substantial, and astronomers had to explain not just one strange event, but the entire pattern. The mystery became even more famous when researchers considered a much more extraordinary possibility. What if the material surrounding the star was not natural debris at all? Could an advanced civilization have built enormous structures around its star to collect energy? The idea became known as a possible alien megastructure, often imagined as a vast collection of objects orbiting the star. It was an extraordinary hypothesis, but it was only a hypothesis. There was no evidence proving that an extraterrestrial civilization had built anything around Tabby's star. And as observations continued, the story became more complicated. Because the real question was no longer simply, what is blocking the star? It was something much harder. What kind of natural process could create such an unusual pattern of disappearing light? The answer began to emerge when astronomers stopped looking only at the dramatic dips. They started examining the star's light across different wavelengths. This matters because dust does not block every color of light equally. A large opaque object, something like a solid planet, could block starlight in a relatively similar way across visible wavelengths. But tiny dust grains behave differently. They scatter and absorb shorter wavelengths more efficiently, which can leave a measurable color signature. And observations of Tabby's star provided evidence that the material responsible for at least some of its dimming was consistent with very fine dust. That was an important clue. It made the mysterious object in front of the star look less like a gigantic solid structure and more like clouds of material. Another clue came from long-term observations. Tabby's star was not simply experiencing a few dramatic dips. Astronomers also found evidence that its brightness gradually changed over much longer periods. This suggested that the phenomenon might involve more than one isolated event. Something around the star appeared capable of changing the amount of light reaching Earth on several different timescales. But what could create such a complicated environment? One possibility involved comets or other bodies breaking apart. A large object moving close to the star could produce enormous amounts of dust. That dust could then spread along its orbit, creating irregular regions capable of blocking some of the star's light. Other ideas involved collisions between planetary bodies, clouds of debris, or unusual structures within the star's surrounding environment. None of these explanations has become a simple, universally accepted answer to every feature of the observations, and that is important. Tabby's star is not a solved alien mystery. It is a real astronomical mystery whose observations have been interpreted through increasingly natural explanations. The famous megastructure idea also became much less convincing as scientists gathered more evidence. If an enormous artificial structure were responsible for the dimming, astronomers would expect additional clues. For example, large amounts of material absorbing visible starlight could potentially produce excess infrared radiation as that energy was re-emitted as heat. But observations did not reveal the kind of strong infrared excess that would naturally support a giant swarm of artificial heat-producing structures. That does not prove that extraterrestrial life is impossible. It simply means there is no solid evidence that an alien civilization explains Tabby's star. And that distinction is the most important part of the story. The mystery was never really about proving aliens. It was about discovering why a distant star behaved in a way that standard planetary transit models could not easily explain. Today, Tabby's star remains unusual. Astronomers have gathered evidence pointing toward dust and other natural material, while continuing to investigate exactly where that material comes from and how it is arranged. The dramatic dips that first captured attention may have natural explanations, but the full history of the star's changing brightness is still an active area of research. And perhaps that's what makes Tabby's star so fascinating. The universe did not need an alien megastructure to surprise us. It only needed a star, some dust, and a pattern we had never seen before. Because sometimes the most powerful scientific mysteries are not the ones that prove something impossible. They are the ones that force us to admit that we still do not completely understand what is happening. So somewhere in the constellation Cygnus, Tabby's star continues to shine. And every time its light reaches Earth, astronomers get another chance to ask the same question. What exactly is passing between us and that distant star?